Today we're going to be taking a look at slope and equations of a line. So we're going to find the slope between 2 points, identify the different types of slope, and examine slope as rates of change. So even though through previous classes we've taken a look at slope, just understand that all it represents is an expression of change. And this expression of change is commonly the y variable, so the change in that y variable, as it corresponds to the change of another variable that we call our x. And that's the more common way of looking at it. And so a way that we can express it, change of y over change of x. So we use that notation. And through equations, we're going to say that our slope is going to be represented by m. Now let's take a look at an example of this. Let's say that we're trying to sell pies at lunch as a fundraiser for the Interact Club, and we determine that our profit in dollars can be represented by a line with a slope of 5/2. That means that 5/2 is a change in $2.50 in profit for every one pie that I sell. So if I sell one pie, it's $2.50. If I sell two pies, it's $5, and so on and so forth. Now these are the different ways that we take a look at this. So we could say that slope is the change of the dependent variable over the change in the independent variable, or the vertical change over the horizontal change, or the change in y over the change in x, or the rise over run. And these are all the different traditional ways for us to be able to say that or represent what slope's going to be. But ultimately, for the formula, we're going to use the slope, which is the change of y over the change of x, is y2 minus y1 over x2 minus x1. Now to find the change in something, you subtract the two different values, and that's why it's the two different y values divided by the two different x values. And so that's going to be the change in y's over the change in x. Now looking at an example here, I could just say, all right, well, here's my points. Here's my x1 and y1, there's my x2 and y2, and comparing that to my rise over run, well, my rise is 2, so it's going up 2, my run is going to be 3, and so I can say my rise over run is 3. But now taking a look at this with the points, well, y2 minus y1 over x2 minus x1. Now when I plug those in and simplified it, I got the same rise over run, which is 2/3. So understand that visually we can look at that and look at how much it moves up divided by how much it moves over, or up and down I should say. Or I can just find the points, which is 1, 1, and 4, 3, and I can plug them straight into the formula to be able to simplify it. So if I want to determine the points, or the slope between these 2 points, we label our x1 and y1, here's our x2 and y2. Now please don't get confused about this notation of x1 and y1. It's literally 0.1, so I'm going to say that the subscripts are 1. This is 0.2, and so I'm going to say my subscripts are 2. And so all I'm saying is it's the x value to 0.1, the y value to 0.1. This is the x value to 0.2, this is the y value to 0.2. So all we're doing is we're just taking those values and then we're plugging them in. And so plugging this in and simplifying it, 15 minus 7 over 3 minus 1, 8/2 is going to be 4. Now, what happens when my y values are the same? When we plug those in, we're going to get a 0 slope. Now that's okay. We can have a slope of 0. What happens when my x values are the same? Now notice when I plug those in, I get 0 in the denominator, which is going to be an undefined slope. Now what happens if the points are the same? If I plug those in, we call this 0 over 0 the indeterminate case. Now this means something, and that meaning, granted, is not going to be examined fully in this class, and we'll be taking a look later on in calculus. Now there were these two special slopes that we looked at. One was that slope equals 0, and then the other one was the slope is undefined. And what we're going to do is we're going to take a look at those a little bit more closely. Now if we ever get a slope that's 0, even thinking about it, that just means that my line is going horizontal. Well, we talked about this previously. That's just going to be the equation y equals a number. So because I know that this line is crossing that 2, I know it's going to be y equals 2. This has a slope of 0. let's find a few of these. If I only had a point and I said, hey, find the equation of the line passing through that, well, if I know that my slope is going to be 0, it kind of helps us to remember y equals the number. So we're only looking at the y value. So it's going to be y equals 10. Now even visually, I have this point. 1, 2, 3, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Well, it has to pass through it. We know it's going to be a slope of 0. And it's a little slanty, but you understand what I mean. Okay, that's a little better. But it's just the idea that it has to create that 0 slope, which is going to create that horizontal line, which is why it's y equals 10. If I had the point 2, negative 14, well, if this was 2 and this was negative 14, and that's my point, it's going to create that horizontal line. So y equals negative 14. 13, 38, negative 13, 38, that's going to be y equals 38. Negative 11.2, 10.4, it's going to be y equals 10.4. Now, if we ever have this undefined slope, which means we have a number that's divided by 0, it's going to be x equals the number. Now, taking a look at it, y, if we look at our notice, what is that slope? It's like the sheer cliff of death. I mean, there is no slope. There is no rise over run. It's just an infinite rise with no run at all. And so, because there is that infinite rise with no run at all, that's why we call it infinity, which is undefined, and that's why we have an undefined value. But understand that this is going to be x equals negative 1 because it's going up and down at negative 1. But understanding that it's going to be x equals the number is going to be crucial, because take a look. If I wanted to find the equation of the line passing through this point, well, let's examine this. Here's negative 13, here's positive 11. Well, if it's undefined, it's going to go up and down like that. And so that's going to be x equals negative 13. That's why I said x equals the number. For this one here, let's kind of visualize that one. If I have negative 12, negative 14, that's going to have to move up and down. And so that's why it's going to be x equals negative 12. Same thing here, x equals 76. Same thing here, x equals negative 5.21. And so x equals a number. It's kind of like the shortcut, but being able to visualize what's going on, that's going to be the most important. Now, in a previous slide, I used this phrase, change in y over change in x. We use this Greek letter delta to write the change in y as this statement and the change of x as x1 minus x naught. Now, this could be the same as y2 minus y1. This is x2 minus x1, right? It's all the same. I'm just, however it is I want to phrase, I'm phrasing it. Now, in most scientific circles, that symbol means change. And since that's why I said my m is going to be the change in y over change in x, which describes slope as the rate of change with y in respect to x. So let's take a look at a few examples. Suppose that 2 separate temperature readings were taken at the ranger station on top of Mount Sasquatch. At 6 a.m., the temperature was 24 degrees Fahrenheit, and at 10 a.m., it was 32. So find the slope of the line containing these points. Because at 6 a.m., it was 24, so there's 0.1, and at 10 a.m., it was 32, so there's 0.2. And so I could find the slope, m equals 32 minus 24 over 10 minus 6. And so that's going to be 2. And so part 2, it says, interpret your answer to the first part in terms of temperature and time. Well, because I found that it was 2, that 2 means the rate of change. So it's going to be a 2 degrees in Fahrenheit increase per 1 hour. Okay, so it's just 2 degrees, that's what it's changing per hour. Predict the temperature at noon. Well, if it's going at this current trend, noon is 2 more hours from now. And so having 2 of those, and if it's going to increase 1 hour per 2, that means that in 2 hours it's going to increase to 4, and so 32 plus 4 is going to be 36 degrees Fahrenheit. And so just by that slope, I was able to predict the future of how it was going to be. To close the lesson, what is it that we learned today? Well, we examined slope and the various rates of change, how the slope formula works and interacts with a point or a couple of points, And then we also took a look at how we can take this rate of change and apply it to a real life example. And so I want to hear from you. How do I find the slope from those 2 points, or maybe even a set of points, and then create an example that represents a rate of change? And you may do a little research on that, but I just ask that you try and make it unique and not just look at the comments and, it's like, oh, that's a great example, I'm going to use it as well. Well, this does conclude our lesson. If you have any other questions, please leave them in the comments.